Welcome Dart Players one and all. Today on Straight to the Point we're going to be talking about the impact using different flights and shafts have on the dart itself from an aeronautical perspective. So the number one rule to remember is the thinner the object, the faster it will fly through the air. The thicker the object, the slower it will go through the air. The flight I use is a pear shape which also has a very small circumference, which means it travels quite fast as well. If we compare it to the nylon equivalent, that nylon shaft is quite a lot thicker than the aluminium, which means it will travel significantly slower. Flight on the nylon shaft is also slightly thicker as well, that's 100 microns, whereas I'm using 75. Very similar. If you compare that to this Robson flight, you can see a dramatic difference. So again, this will really slow the dart down. The length of the shaft will also play a big part when governing the speed of the dart mid-air. As the further the flight is away from the barrel, where the weight is, the faster the dart will travel. This does mean that generally the shorter the shaft you're using, the smaller the flight you can get away with, while still having plenty of lift in the rear of the dart. It's important to mix and match different shaft lengths with different flights. Look at my barrel here. I use a very wide barrel, 7.2mm, which causes the dart to travel much slower than a thinner dart would. When you combine this with the fact that I have quite a slow follow-through to my throw, this is why I prefer a thinner flight and shaft. It just speeds that dart up, because my arm is very, very slow going through with the dart. Other players who have a very slow follow-through, like Ted Hankey and Steve Beaton, also use an aluminium dart shaft. Notice as well, other players who have a much faster follow-through, like Michael Smith or Michael Van Gerwen, tend to use nylon. Whether they know it or not, this is the physics behind why they probably prefer that setup. So this is trial and error. However, by knowing this, you can sort of determine what might be best for you to try next. Another thing to note is that if you look at the length of this nylon shaft compared to the aluminium, it does look significantly longer. However, they will play very, very similar, as it's the difference between where the flight begins and where the barrel of the dart meets the shaft that causes the speed of the dart to alter. The only thing that's going to change the speed of the dart travelling between these two is the thickness of that stem. So now I'm going to try and prove this point by using the very limited amount of technology I have available, but we're going to try and time the dart between the very second I start to accelerate through with the dart and thrust forward to the time the dart leaves our screen. I've recorded this with a fine-tooth comb, and I begin to thrust through the dart at exactly 2:10.04 seconds. And if you look at the point in which the flight leaves my hand and goes off our screen, right almost there, there. It ends in exactly 2:15.40, so it's roughly 0.5 of a second using my setup, which should be the fastest. On this next dart we're using pretty much the same setup with the nylon shaft though, the nylon equivalent. And I start the thrust through at 232.8 seconds, and that flight leaves our screen at exactly 238.6, so 0.6 of a second. So there we have it. It is microscopically a bit slower, but on this last dart we should see the biggest difference of all. So this was using the big Robson flight. We thrust through at 239.9 and it leaves the screen at 247.1, 0.8 of a second. Bearing in mind as well, the camera is about half a foot away from the surface of the dartboard, so this would also be exaggerated a bit more by the time the dart hits the board. So there we have it. That's it for today. That is why players prefer different setups on their darts. Please remember to like and subscribe, and as always, I really do hope this helps your game. Thank you for watching Straight to the Point.